Me too. So it's probability with normal distributions. Outline of presentation.
Oh, so I got a whole group. They do still want to meet together. It's just 2 other people. And they can meet on Mondays and Thursdays.
Mondays and Thursdays, what time though?
Yeah. I told them it had to be the evening because you had work and I had classes. And the latest that they would go is, I think they said 5 o'clock Mountain Standard Time. So it would be 4 o'clock your time. And I don't know how that would work for you. Because
I don't get home till 5.
Yeah, that's what I was trying to tell them. But Sister Cook is like persistent about us joining another group because she wants more people in a group for the end of the year project. But I don't know how that's going to work because I guess one of them lives in Georgia and she doesn't want to do too late. But I mean, like 5 o'clock Mountain Standard Time is still only 7 o'clock Georgia time. So I think it's fine if we meet a little later.
Maybe I can. Do you know who they are? Maybe I can reach out to them and ask them to see if they can meet just an hour later.
Yeah, I have their emails. I can email them to you.
Okay.
Yeah, but I think an hour later would be a lot easier. All right. Here. Did you have like any questions?
No,
not preparation assignment. Okay, I thought it was kind of easy.
Yeah, it was kind of like a review.
Yeah, pretty much.
I'm gonna open the group meeting.
Okay.
I'm hoping that the exam coming up isn't as difficult or as tricky, or that I don't read too much into it.
Yeah.
So I have number 3 set up where it says use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equaling 1.358 and to the left of z equaling negative 0.358. Round your area to 3 decimal places. Example, if the answer is 0.897. Oh, we had this one before.
We've done these before.
Yeah.
So on the normal applet, we would just put in those numbers.
Yeah.
And then we highlight the 2 sides. We leave the middle unhighlighted.
Yeah.
So the area, I got 0.1745.
175. I haven't done the math. That sounds right. Because it's got to be less than 2 on either side.
Yeah.
So it's 0.175?
Yeah, that's what I got.
Okay.
All right, number 4.
Hold on, Nelly. I just got a phone call from my mom.
Oh, you're good.
Hello? Pick it up? Can I do it later? Oh, I don't have the key to get into your house though, Mom. Okay. Okay, I'll go later. Okay, bye, Mom. Okay. Sorry.
You're good. All right. Number 4. The United States Coast Guard assumes that the mean weight of passengers in commercial boats is 108. The previous value was lower but was raised after a tragic boating accident. The standard deviation in passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is an extreme or more extreme, either above or below the mean. than was observed in this sample. Okay, and then it just says no, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in the positive direction.
Okay.
Okay, let's see where we start. So we're looking for the probability that a random sample will have a weight that is extreme or more extreme than the observed sample.
Yeah.
So I don't remember how to do these. Okay, so this is p-value.
Right off to me.
Okay.
The previous value of lower passenger sample determined. Extreme.
Okay. So we're looking for the p-value. But
Yeah.
I don't remember. I don't really exactly know how to find it. All I wrote down is that the p-value is calculated by finding area under the curve that is more extreme than the z-curve, z-squared.
What lesson would that be from?
7.
No, but you know how sometimes it leads up to? Because 7 to me was more kind of like a preparation for the upcoming exam, where it kind of ties into some of the things that we did before.
Yeah.
Find area normally distributed, and this is a normal distribution.
Yeah.
Okay, so it has a formula. The last page, it says, but this gives you a z value. It says, and you're looking for p.
No, I don't think it gives you a z-value anywhere. Because
No.
it gives you the mean weight of the population, standard deviation of the population, and then it gives you the sample size, and then it gives you the sample mean and the sample, and it wants to know what the sample standard deviation is. So we have all the means and we have the population size. We just need the standard deviation of the sample. But I'm a little confused how to find that, I guess.
Parent population is normally distributed. Finding the area. What is it? What are they looking for? Hold on. Let me read this.
They're looking for the sample standard deviation. Okay, so in the lesson 7 notes
find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in this sample. So are they looking
so that
for
just
the
means I think that just means like standard deviation.
Oh.
Like having an extreme is like one standard deviation to the right or to the left. And the p-value is a probability of getting one of those. And we're looking for the p-value, but to find the p-value, we have to find the standard deviation, I think. But I'm not exactly sure how to do that.
Because the last part of the PowerPoint presentation, it has little PowerPoints, and the last one says find the area or probability within a distribution of sample means when population data is not normally distributed. Would that fit this?
I don't know, because it doesn't tell us that it's normally distributed, so.
Because it has formulas. There's one for finding the area or probability within a distribution of sample means when population data is normally distributed. And then it says review mean, standard deviation, shape of distribution of sample means when the parent population is not normally distributed. Huh. Standard deviation. You want to skip that one and come back to it?
Yeah, I think so. Okay.
It says number 5, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of individual observation, the distribution of sample mean. This cannot be determined from the information given. So I remember this: the smaller the population, the smaller the deviation from.
I think it can't be determined because we don't know any other numbers other than 9, and we don't know which one's smaller.
That's true.
Okay. All right. Which of the following results imply that the spread in X bar decreases as the sample size increases?
Was that the central limit theorem? Hold on. Okay.
Oh no, it's the law of large numbers.
Okay. See, and that was the previous lesson. So the one that we skipped, we must be able to find it in one of the previous lessons.
Probably.
It says score on quantitative portion of the GRE are approximately normally distributed with the mean of 150.8, a standard deviation of 8.8. Use this information to answer questions 7 through 10. It says Diane earned a score of 160 on a quantitative portion of the GRE. What is the Z-score corresponding to Diana's score? Round your answer to 3 decimals. Okay, so that one, I just saw that. Okay, honey. You can. So,
do we just take 160 minus 150.8 and then we divide it by 8.8?
Not the square root of that?
No, that's only if we're finding the sample mean. This is the population mean that they're giving us. And they didn't give us any sample size, so. All right, and I got 1.045.
So 150.8 minus 160.
Oh no, it's 160 minus 150.
But why don't you count the 0.8?
You do. I was just saying it passed. Yeah, it should be 160 minus 150.8.
Okay.
And then you divide the standard deviation.
Right. 2 by 2. So 5. 9. So 9 divided by, let me get a calculator. Sorry.
You're good.
You got 1.045?
Yeah.
Yeah. Okay.
All right. Number 8 says, what is the probability?
Did you round it up to, Ellie, though? Did you round it up to 1.05 then?
No, you need 3 decimal places.
Oh,
so you
after
need
that.
those
Oh, I see.
decimal.
I see.
All right. Number 8. What is the probability that a randomly score above 160 on the quantitative portion of the GRE? All right, so we go to the link and then we type in 1.045 into the box for the Z-score. And then it's asking for above that, so it would just be above the first portion.
Okay.
So it should be just what the area is, which is I got 0.148. But like that's
And
not
that's when you
right.
typed it into that little Appulette thing, right?
Yeah.
So if we do 160 plus point, you know how you can figure it out manually?
Yeah.
Plus that is 3 higher.
Yours is what?
Yeah. So it's 1.48. 048. I think I lost her.
Yeah. That's what I got.
48 or 08?
I got 0.148.
48. Okay.
Okay.
So number 9 says random samples of 5 students were selected to take the GRE. Their scores were 160, 175, 63, 149, 153. What is the z-score corresponding to the sample mean of these students' scores?
Okay.
So we have to first add those and then divide it and find the mean?
Yeah. I'm pretty sure we do that.
Okay. So 160.
I just got 160 for the mean.
Okay. Divided by 5. Yeah.
Oh, okay. So then the z-score would be the same as in number 7.
Would be 1.0.
Oh, no. No, it wouldn't. Because when we're given a sample mean, then we do the standard deviation divided by the square root of the sample size.
So then
So
this is the mean.
So we get the mean, which is 160,
Uh-huh.
and then we subtract the population mean, which is 150.8,
8.
and then we have to divide it by the standard deviation. But the standard deviation per sample
Has to be the square root.
Yeah, so you would do 8.8 divided by the square root of 5. And then you get like 3.9354796. Yeah, you get that long number.
9.2. And then
What'd you get?
Hold on. I'm trying to figure out the square root of 8.8.
Oh no, you divide this. You take the square root of the sample size. So you put 8.8 divided by the square root of 5, because there were 5 students.
Okay.
And that when you do that, that's the same thing as the standard deviation. So for the standard deviation, you should get 3.9.
3.52.
I got 3.935.
Okay, hold on. 9.2 divided by 3.
It might. Hold on, let me look.
But you know how when you subtract the 160 from 150.8?
Yeah.
Let's see. Minus 150.8. So I have on top 9.2, and on the bottom I have to take that standard deviation and divide that standard deviation by 2.5, right?
Kind of, yeah. So here, if you look at my screen, you can see my calculator.
Oh yeah.
To find the standard deviation sample, you have to take the standard deviation of the population, which is 8.8, and then you have to divide it by
the square root of
the square root of 5, which I don't know what the square root's at. I can't find it. I don't know where the square root's at, but that's pretty much the idea.
Let me see what the square root is. Huh? Ah, it won't do it. Yes, awful math. No, just kidding. It's 2.23. So.
Okay. So you would take 8.8 divided by what you got for the square root of 5.
Be 4. So then I divide 9.2 divided by 4, right?
No, okay, so 8.8 divided by the square root of 5 should equal 3.9.
I don't get 9 though. 8.8 divided by the square root of 5. Oh yeah, 3.94.
Okay.
But then I take
the
number on top, the 9.2, and divide that by 3.94.
Yeah.
Okay.
So you should get 2.34. Oh, 3 decimals, so 2.338.
I get 2.3469.
Really? Oh, okay, yeah, that's right. I just rounded mine.
3, 4, 7. So we're gonna put down 2.347.
Yeah.
Okay.
All right, number 10. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So I think we just put the z-score into the normal applet.
Yeah.
And then
I don't have the applet open.
Oh, it's good. So it should be 0.0097.
That's so low, huh?
Yeah, and then we can leave it like that because it says we can use 4 decimal places.
0.0097.
All right.
You said 0.097?
0097.
0.097.
There's 2 zeros.
After the point?
Yeah.
Okay. All right. It says, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that that this distribution is left skewed. A random sample of n, 81 students, will be drawn. Use this information problems 11 through 15. This is from last week's or the week before's stuff.
Yeah.
Okay, so it says, what is the shape of the sampling distribution of the random variable x, which represents the sample mean of 81 students who are selected? So it's left skewed, right?
Yeah, because it still follows the parent population, which I think. No, I think it's normal. Because in lesson 6, we learned that if the population is not normal, which here it's left skewed, so it's not normal, then the sample mean will be normal if the sample size is big. And we also learned that if the sample size is over 30, that makes it
big. That means it's big.
So that means that this is normal.
Yeah, normal. I'm pretty sure. Notes on that.
All right, number 12. What is the mean of the distribution of the sampling distribution for all possible samples of size 81 that could be drawn from the parent population? Okay, I don't get what it's asking.
Hold on, I'm trying to get to that last sentence. It was 5 or 6. I can't remember. Okay. So let's see. It says, what is the mean of standard distribution? What is the mean of distribution of the sample mean? It's throwing me off because it says the mean of the distribution of the sample means.
Yeah.
Huh. Hold on.
Okay. I don't know how to do this.
I'm trying to figure it out.
Yeah, I don't even know what it's asking.
I can't tell what it's asking. It says, what is the mean of the distribution of sample means? Sampling distribution. What is the sampling distribution? It is well known that this distribution is left skewed. For all possible samples of size 81 that could be drawn from the parent population. Round your area to 1 decimal place, for example, 1.2. Oh. Is it normally distributed, or we don't know if it is?
I said it was normal.
Okay. So let me go to that. Next.
Okay.
Okay.
I don't even know where to start on 12.
I read through that. I read that one too, and I thought again, and I'm
I
like,
don't really I don't know.
13 and 12 are the same. Because it says, what is the standard deviation of a sampling distribution? Wouldn't the standard deviation of a mean? But the above question says, okay, you have 81 students whose GPA is 3.5 and the standard deviation is 0.7. It says a random sample of N 85 students will be drawn. So if it's with that sentence, wouldn't the standard deviation of that mean just be that 0.7 for 13?
No, because that's of the population. That's the standard deviation of the population, and we're trying to find the standard deviation of the sample.
So then if I'm looking at this correctly, and under in lesson 6, under their lesson, it says that if the mean of population is then the mean of the distribution of the sample mean is the same thing.
Yeah, it might be. I think I remember that, yeah.
It says, regardless of the sample size, the shape of the distribution of the sample mean is normal. The center, if the mean of the population is, whatever that mean is, then the mean of the distribution of the sample mean is the same number.
I say mean.
I know.
Okay. So it would just be 3.5.
Yeah.
And then the standard deviation would just be 0.7 divided by the square root of 81.
Yeah.
Well, that was like way easier.
What did you get when you calculated the number 13?
0.078.
0.078. Okay.
Okay, we're overthinking that. Okay.
So
All
14 says, what is the probability that the GPA for 81 randomly selected BYU students will be less than 3.3?
Probably that mean. So
this is the one where we subtract the, Caleb, don't please.
we find the z-score.
Yeah.
So 3.3 minus 3.5 divided by the standard deviation, 0.07. That's negative 2.56.
We can't have a negative number though, huh?
It's a z-score, so we still have to find the probability. So we put it into the normal applet, and then we find anything that's underneath it. So for the z-score, I got negative 2.564.
Okay.
And then I put it in the normal applet, and I found everything underneath it. And the area is 0.0052. So it would just be 0.005 because we need 3 decimal places.
Okay.
So, all right, number 15 says...
Oh, greater than. So do the same thing, just plopping it into the...
Yeah, okay, so it is 0.9948.
So it would be...
So it would be 0.995. All right, we need to do number 4.
I don't know if they're cooked, Caleb, Diego. Okay. But I haven't done the broccoli yet. Okay. I have no clue. Let me think about this one. Assumes the mean weight is 185 pounds. The previous value was lower, but was raised after a tragic boat accident. The standard deviation of passengers' weight is 26.5. The weight of the random sample of passengers. Oh, it's not done, Diego. I'll be right back. Ellie.
Okay.
Yes.
Okay.
I just have to put something in the microwave first.
You're good.
Okay.
Okay, so this is just like the ones we were just doing. So we take 177.6, the sample mean, and then we subtract
minus
the mean.
185.
Yeah, and then we get negative 7.4. And then we find the new standard deviation. So we do that by doing 26.7 divided by the square root of 48. So,
48,
so the standard
24.
deviation. No, the square root of 48 is 0.928. So 26.7 divided by the square root of 48 is 3.85. So if we do 177.6 minus 1, and then divide that by 3.8.
One 1.94.
I got 1.92, but I didn't round, so. All right, so we put that into the z-score, so negative 1.92, and then we have to find
the probability that a random sample of passengers will weigh that is as extreme or more. So I guess higher than
yeah.
the observed
So
sample.
it would be 0.973.
Too bad we can't take this test, as a group
Yeah, I
to
know.
bounce off like, oh, what does it say?
All right, let's see how we did. Oh, we got number 4 wrong.
Oh,
And number 5.
oh, so yeah, it's a distribute. Okay, that's okay. I wonder why we got number 4 wrong.
Yeah, I don't really know how to do that at all.
Because it would have been the same, like you said, it would have been the same one, like the ones below, like 12 to 15.
Yeah.
Huh. Let's see. 5 says, which of the following will have a smaller standard deviation if 9 observations randomly drawn from a population? The distribution sample made. Okay. I think it was more. I think it was more just of a statement than, let's say, if it was a number 30 or larger.
Yeah.
Okay.
All right. Well, let's plan on meeting Monday, 6 o'clock your time.
Okay.
And I'll go ahead and email the other 2 and let them know that's what time we need to meet.
Okay.
And then if there's a problem, we can just figure it out. But
okay. Sounds
all right,
good.
that sounds good.
Thank you.
Yeah.
I'll see you.
Bye.
Have a good week. Bye.
You too.